All right, so continuing on with translations and transformations, and I think they're the same thing. Today's parent function. Now, if there's actually, this goes a lot deeper than what we're doing, especially in Algebra 2. But years ago, we decided, hey, let's have just a base of 2, and that will be our parent function because it's actually one of the easier ones to see. Okay? Now, if this is your parent function, yes, you have decimals as y's. Okay? Used to, pre-COVID, it would be, you'd actually have to graph this. If your graph somewhat looked right, you got a point for it, but we really wanted to chart. Can you find these y values? Okay. And, you know, trying to graph a decimal is super difficult. So, thank goodness for technology. But you don't really have to worry about the graph if you don't want to. I mean, if you got the y values, you could always go back and graph it as you need to. Okay. But we're going to build off what we looked at yesterday with h and k, with the absolute value and linear, and kind of move on through this. Okay. Now, all right, we're not going to click the star for the link. All right, asymptote is a line that a curve approaches as it heads towards infinity. Okay. The best way that I think of an asymptote is like one of those in-ground electric fences, like the invisible fences for dogs. Okay. They get close to it, and the collar starts beeping, but they never, if they do cross it, gives them a little bite, little kind of thing. So what it does is that this graph, it will get close to a certain value, but never touch it. Okay. Yeah, take the pass. So what now? Okay. And in the exponential functions, we have a horizontal asymptote, and it's y equals k. That's the equation for that. All right. I think last year when I taught this, I said, how many of y'all have seen an invisible fence? And like half the class raised their hand. I'm like, how did you see an invisible fence? Yeah, you can see the little flags. So, all right. Yeah. You usually see where it's put in the ground, See, whoops, too much. There. Now it's more better for y'all to see it. But, it says press star for link. I never do that. Okay. I should have took that out. Maybe I'll do it next semester. Just depends on what 2021 looks like. I'm not going to buy a calendar for next year until I see the trailer for the year. I wonder if this year will have an after credit scene like the Marvel movies. That would be funny. Yeah, that would be funny. All right. Now, so this stuff right here, this is your main equation. All right. H, again, remember it's backwards. If it's positive, it goes left. If it's negative, it goes right. Okay. And K is up or down. Okay. And K is also our asymptote. That's going to be the value that we get close to, but we never really touch. All right. And there's something that I've added, and I'll probably give it to y'all after we get back from Thanksgiving break, that it basically reviews all these rules together. I call it like Jeffrey shortcuts or something. And I'll let the students use it on the test. And it was very helpful last year. All right. And to get the Y values for when you do something, you just apply K to this. Like if it's plus K, you add K, that K value to all of these. Okay. If it's minus, you subtract it to all of these. Okay. That's when we're dealing with this stuff right here. All right. So let's look at number one. All right. Now I put the parent function on here. Okay. And on this, h equals 0. Believe it or not, our h goes in the middle right here. But that's the only value that does. Okay. Now, our k value is -4. All right, so our transformations is going to be down 4. Our y-intercept, we're not going to worry about that right now. And this asymptote, we're going to look at its y equals -4. Okay. Now, to get these y values, okay, I copied this right here, okay, from that other slide. We're actually going to say the following, like 0.25 minus 4. Well, that's -3.75. Okay. 0.5 minus 4. Well, that's -3.5. 1 minus 4, -3. 2 minus 4, -2. I'll spit it out here in a second. And 4 minus 4 is 0. Okay. And that's kind of how that works for the y values. Okay. Used to, we tell students to plug it all in their calculator. They would jack it up all the time. They would mess it up. But it's literally the same thing. Okay. So if I was to graph this, if I was to graph this, and I'll do it in the hot pink again, this like I did last time. All right, so I go over to -2, 1, 2, and I go down 1, 2, 3, and almost a 4, and then in between, and then a -3, -2, and 0. So it should look exactly like that parent function in black, just shifted down. Okay, and then we said that our y, this is our y-intercept, is at 0, -3. Okay. And again, the first one, I don't expect everybody to totally understand it on the first one. If you do, then you probably should have been in another math class. Okay. That's why we always have more examples. We have to solidify it and stuff. Okay. No. Yeah, no, you subtract it from these values right here. That's from that parent function earlier. Look back up here as soon as I can get there. See where this is on your paper? Yeah. Those are the y values. I said like 0.25 minus 4 because -4 was our k all the way through. Yep. Okay, now let's look at example 2. We have no x values. We do not know what to do. Or do we have any x values? All right. And this one, h, is 3 because it's written as minus 3, so it's the opposite. This goes in the middle. All right. Well, on the number line, it should go 1, 2, 3, 4, 5. All right. What is k for this one? It's 0. So if we added 0 to these numbers right here, we would get the same thing. So it's just those values for the parent function. Bless you. All right, our transformations. We have this goes to the right, 3. Okay. And then again, I'm not really worried about the y-intercept because we would actually have to go down another one, and that would be like 0.125. I mean, we don't even have that x when x is 0 up here, so I could care less. All right, but our asymptote, well, if our k value is 0, it's just y equals 0. That's our x-axis. All right. So we can go now and plot these. So I go over 1, up 0.25. Over 2, up 0.5. Over 3, up 1. Over 4, up 2. Over 5, up 4. So it looks very similar to our original function. It's just shifted over 3 places. Okay. Yeah, this was everybody. Every year I've taught this, they're like, "How in the heck do you graph a decimal?" I'm like, "Just get close." I said, "There's no way for us to efficiently graph a decimal unless I give you a grid with decimals on there." Okay. So we really focused on the chart from this in the years past. Now, on the homework and stuff, it will have like match the equation with the graph, and you can tell like it's either shifted one way, either down or up or left or right, and it's a lot easier than you think. And I've already double checked to make sure there's no typos or mess ups with the key this time. But yeah, I've checked, and now there's going to be some, so that's awesome. All right, example 3. This is our h right here. Our h is going to be what? What's the opposite of plus 2? Minus 2. That means it goes to the left 2. And also this negative 2 goes in right here. Well, this would be negative 1 and 0, 3, 4. Those aren't all supposed to be that color. There we go. That's more better. All right. Our k is negative 8. So this means it goes down 8. Now, I would take these values right here and subtract 8 from them. All right, so 0.25 minus 8 would be negative 7.75. Our 0.5 minus 8 is negative 7.5. 8 or 1 minus 8 is negative 7. 2 minus 8 is negative 6. 4 minus 8 is negative 4. So now we have our values. We could actually graph it. Okay. And the only real reason I'm having y'all graph these is to hopefully get the concept. Okay. So if you're a bad grapher, don't worry about it. This one, we can do the y-intercept. This would be 0, -4. And our asymptote is y equals -8, because we get really close to -8, but we never really cross -8. Okay. We just get really, really close. All right, so 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, and almost to 8. And then up and here, here, and here. All right. Now, on your handout, there's the your turn is next, correct? Okay. It's kind of like when you watch previously recorded sporting events that says, due to time constraints, we're going to move you ahead into action. Okay. We're going to come back and go over this your turn in class. I'm not going to do it recording for our quarantine people. Okay. They're just out of luck. All right. We'll come back to this. All right. So this one right here, these three, this is what I would start off if I were y'all. I would start off and write y equals 2 to the x on all these, because that is our parent function, and then we're going to do our h's and k's from there. All right. So this is a exponential function that's been translated to the left 5. All right. This is a h. So normally it's minus h. Well, if it goes left, that would have to be negative to make this positive. So it's the opposite. So it's plus 5. All right. And b, exponential function has been translated up 10. So this is our k value. So we just have to go over here, not in the exponent, but just regular, and do plus 10. Yeah. Why is it opposite? All right, remember, this is 2x. I should have done this earlier. All right, that's our definition rule. That for some odd reason, when you do something to the exponent, it makes it shift left or right. Why is there an h right here? This. Why is the h in the exponent? All right. So, got you. So it's very similar to what we had yesterday. Okay. If it's already written as negative, okay, and the original definition says if it's given as negative, it goes to the right. Okay. So if this was to go to the left, that would actually mean h would be -5 right here. Okay. So if I plug in this would be y equals 2x to the minus -5. Well, what's minus negative? Yeah, it just changes the sign. And the h thing is the one that people have the hardest time with. It's in the exponent because that's where it's supposed to be. Okay. All right. So this is translated to the right, so this means h equals 1. And down 7, this means k equals negative 7. So this would be, oh, no, not a plus. So minus, and then 1 goes here, and then minus 7 goes there. All right. And that's the lesson. Good stuff. Good things. Roll Tide.